So we're going to talk a little bit about cybersecurity. I noticed in previous talks that people were very eagerly taking pictures of slides, so I made sure that you don't have to take pictures if you don't want to. The slides are already online. If you go to slideshow.net/ZRLRAM, I know it's kind of a weird abbreviation. It was my login at IBM Research, and it just kind of was a unique username that no one else uses, so sorry for that. ZRL, Zurich Research Lab, Raphael A. Marty, so whoever is at the Zurich Research Labs, hello. All right, so I want to start with a quick story on cybersecurity. I'm not sure if any one of you has heard about the APT1 attacks. Anyone familiar with that term, APT1? Good. The APT1 attacks happened a couple months ago, and a company called Mandiant, they actually did a long-lasting investigation and found that the Chinese government had a special unit that infiltrated a bunch of corporations around the world. And they named it APT1, Advanced Persistent Threat. They came out with a report that showed all kinds of different sort of tidbits about how the attacks happened, how can we find them in corporations, what corporations were involved. What happened right after the report came out is that there started to be this PDF running around that's called Mandiant APT2 report.pdf. Well, the attackers didn't sleep. Although they were found and we uncovered where they were, they're like, well, we're just going to leverage that as another way to infect more people. So they came out with another infected PDF, which is this one here. They started spreading that in the internet, and people started downloading it because they thought it was an updated version of the original APT1 report from Mandiant. So this is now malware infected. You run this, you open this PDF, it infects your machine through a vulnerability in Adobe Acrobat. And what happens then is your computer starts connecting out to a domain called itsec.eicp.net. That's the node in the middle of the graph here. Basically phoning home to download more malware and start scanning networks and basically furthering the attack. What we did here is we took this domain and went back in time in DNS information and started looking what IP address, what machines have hosted this domain before. And this is not something normal that came out. You see the green dots surrounding this orange dot in the middle. These are all machines / IP addresses that are hosting or have hosted this DNS name before. Generally, you would see generally one machine, because the DNS name points to one machine. Sometimes you have more machines if you load balance things or stuff like that, but having this many here is definitely not normal. What we did then is the next iteration. We said, well, for all these IP addresses, do we know whether any other domains have been hosted on these machines before? And that's the next ring you see further out, all the orange dots surrounding the green cloud. Those are domains that are also hosted on these other machines or have been hosted on there. So that means now that basically all these green dots are machines that are compromised, that have been hosting, that have been involved somehow in this APT2 PDF exploit. And all the domains are surrounding, they seem to be infected now as well because the machines are infected now. All the domains pointed to the machines are malicious as well. So what we did is we said, well, not all of them are probably that relevant, but what we tried to do is come up with a graph that kind of helps us to navigate where to look at. And what we did is we used the size of the nodes to be the node degree here in this network. And what you see on the top right are a bunch of larger nodes. And we just started focusing in on some of them, and what we wanted to look at was domains that had multiple IP addresses associated with them. I circled them roughly in that red oval there, and those were the first few domains that we started to look into, and you see they're called help.adobesuite.net, news.livemsm.net. These are not actual real domains, but they're very close to real sites you would go to. So if you fat finger something, there might be a link from somewhere going to there. So these are all potential domains now where this APT or this malicious document was hosted. This is just a very brief introductory example of how visualization is helping us in cybersecurity a little bit to understand the vast amount of data that we have. As in the introduction you already heard, I've spent the last 14 years looking at security data and trying to make sense of all of that stuff. I'm currently running a company called Pixel Cloud. We're building a data analytics framework for cybersecurity, basically helping security analysts and large organizations making sense of all the data that they have to understand where are these things coming in. And interesting to know, this APT1 attack I mentioned earlier, where it was found that the foreign government was owning a bunch of companies around the world, it turned out these companies were owned or were penetrated more than 6 months before they were discovered. They have been luring in their networks forever and should have been detected somehow, but we haven't, because we just don't have the right tools yet to figure out what the hell is going on. And I will show you a little bit why that is and why it's so hard to find these kinds of things. So here's what I'm going to talk about. I'm going to talk very briefly about cybersecurity, give you a couple of statistics, show you why this is an important and interesting topic to look into. I'm going to show you a little bit of the data mining side of security, and mostly showing you kind of what data do we deal with, and why is it so hard to run any of the algorithms on our data that are coming out of academia, for example. I'm going to then show you a little bit why I feel like visual analytics is a very important part or way to look at the data and make sense of what we have. And I'm giving you 3 examples in the security visualization space where I'm going to show you a couple examples of what we came up with and how we did that and where the challenges still are. And I want to end with that with a slide where I pose a bunch of challenges to you. Hopefully you can help me or you can prove me that I haven't done my research right and there's still things we should start looking into. But that's kind of my call to you guys and the broader community to help us out with cybersecurity and helping to apply these kinds of algorithms. So let's talk briefly about cybersecurity. This is very simplified. This is my view of security. This is not the generic cybersecurity problem. There are other issues to solve. There's encryption, there's authentication. I'm not talking about that. I'm looking at it sort of in my little world. And what I'm worried about is identifying attacks before they hit. Ideally, I want to predict when someone comes in, which is incredibly hard, just to say that. I want to know previously unknown attacks. We also call them 0 days in our world. Things that we haven't seen before. We need to detect them before they hit. I want to find attacks when they're in progress. As I just said, some of these companies were infected for 6 months already. I want to find them when they're already going on. And then I want to understand the impact. And when I say attacker or attacks, I mean external and internal. I might have disgruntled employees, I might have insiders that are committing crimes, fraud, all kinds of things. I want to find those as well. If you look at the news, I mentioned this APT1 case was huge, all over the news, a lot of noise created. If you look in the news any day, there's so much going on with regards to cybersecurity. There are new initiatives happening. I think right now there's sort of a cyber war going on between North and South Korea. There's all kinds of things in the news, and it's starting to get, or it's getting just worse from here on, I can guarantee you that. One of the well-known facts of the security community is that every company out there is compromised. Your company is probably compromised somehow. Some computers are not under your control anymore. And that's widely accepted. You can talk to any chief security officer of a large organization, they're like, yes, we are compromised, we just don't know how bad it is. So keep that in mind. Security has also been changing. We have, back in the day, you had these worms spreading and it was kind of noisy stuff going on. If you looked at your network traffic, it was kind of obvious what happened. It was like these widespread things that suddenly hit the news and you were able to kind of take care of them. That has changed. Things are very targeted. They know who they're going after. They're sending very targeted emails to your CEO, try to phish them or lure him into clicking on a link, compromise his machine, start from there. This is very, very targeted, very sophisticated. Motivations have changed a lot as well. What scares me is that nation states on top here, there are all kinds of undercover, you quote, wars or initiatives going on. You have crimeware and monetization as a big, big motivation. The underground economy that has been created by cyber or by cyber warfare, I guess, is incredibly big. It's bigger than the security market or the security, all the money that we spend on all these security products and everything. So it's sort of an asymmetric view of the world at this point. There's a lot of incentive to be a bad guy. Here are a couple statistics that frighten me a lot. We're not just having large organizations being targeted anymore. Like 31% of all targeted attacks have been going to companies with less than 250 employees. So that's even your smaller companies out there. We have an immense amount of target attacks, 116 in a day in 2012. That's incredible, right? So it's kind of scary out there. Well, what are we doing to protect from that? Well, we have defensive security approaches. Well, what we're doing is we have firewalls, we have web application firewalls, we have intrusion detection systems, antivirus, malware sandboxing, all these things I have on here, and you can read the slides later. But basically how they work is they use predefined rules that some expert put in the system at some point. Or they have some kind of known pattern signatures that are encoded in there that try to find these attacks. Well, it's always reactive. We learn from the past, so we're always behind. If we have unknown threats, the 0 days, as we call them, we can't detect them. And we have imperfect patterns, like intrusion detection systems. If you ever played with one of those things, they create an incredible amount of false positives, which analysts are just getting overwhelmed with data, and they will stop looking at them and kind of give up. So defense right now relies a lot on past knowledge. There's sort of two sides in security. One is preventative approaches, where you have a firewall that tries to block the traffic so you can't get in. And then you have the defensive approach, or detection approach, where you're monitoring, well, what is still getting through the firewall? What is still getting into my network? What does that stuff look like? And this is something I found in the Gartner report, and I was very, I guess, pleased and also a little bit surprised. This was a huge report that they wrote, and it said, prevention is fuel in 2020, and it basically talked all about how monitoring needs to be increased. We need to do more monitoring and detecting things, because the way we do prevention or blocking things is not working. So we need monitoring in cyber defense. There's no question anymore. Well, how do we do this from a technical point of view? It's a very simple chart. On the left-hand side, you basically have your data sources, and we have all kinds of sources from firewalls and intrusion detection systems and monitoring operating systems, what they're doing, applications also. We've fused that data together, a very heterogeneous mix. This could be all kinds of different, like it could be syslog, it could be CSV files, it can be from databases that we take in data. There's a whole bunch of different ways we need to get the data. We then fuse it together, we parse it, we normalize it, so we have to impose structure on all of this to make sense of it. We store it in some kind of a data store. We do a little bit of data augmentation. We try to sort of normalize certain things, like if you have a host name in one data log that it's like, I don't know, yahoo.com, and you have an IP address that's actually the same thing in another log file, we sort of have to normalize these things to talk about the same thing. Otherwise, we can never correlate them together, although they're the same sort of thing they're talking about. So there are a couple things we do there in this structured data process. We then take some contextual information, which can be information about hosts, like what's their role, what are user roles, more information about the user, where they're located, and things like that, and try to throw all of that into this data processing engine. We have a lot of rule-based systems where experts went in and said, okay, if we see 5 failed logins, followed by a successful login, well, there's potentially a successful brute force attack going on here. Someone was trying passwords, and then he hits the right one. So there are these rule systems built. There's a little bit of statistical correlation, super simple, mostly sort of sliding windows where you look at volumes of things happening, and if there's a spike in there, like a 100% increase in a certain time frame, then you alert or something like that. These are very simple approaches in general. And then you have sort of event prioritization, which is kind of the holy grail of things. If I have all these events coming in, I want to know which ones to focus on, which ones are high priority ones. And that's something that's incredibly complicated as well. And then from there, hopefully we can generate some alerts, and we do some data presentation for people to look at. Now I want to give you a little bit of a feel for data volumes here. We have 10 different data sources that are giving us data. This can be, as I said, firewalls, maybe operating systems. That's on the sort of magnitude of maybe 10 million events per day. So that's log records. They're all about 200-300 bytes long. Well, that's about 2 gigabytes a day of storage, just sort of roughly. In the context, we're looking at this kind of environment. There's probably about 1,000 entries. It's not very many. The state that we're keeping in these rule engines is about maybe 2 gigabytes. It's probably less. But what's interesting, there's probably one incident in all of this data that we really need to look at, but we're still generating about 1,000 alerts. Someone needs to sift through all of those manually and try to figure out which ones are real incidents. And that's one of our key problems that we have. If you look at technologies, unfortunately, a lot of this is sort of 10-year-old technology that we're using. These systems have evolved, but the problem is we kind of just missed the big data revolution at the point where we started building these systems. There's a whole bunch of new innovation going on right now where companies and startups also, a lot of opportunity here if you're interested, are taking new technologies like the entire big data movement, columnar data stores, and all these kinds of things to rebuild these systems to make them faster, more scalable, and start running some more complicated algorithm on top of them. So to give you a little bit more of a feeling for what we're dealing with here in terms of the data, I have a bunch of challenges here that we face. On top you see an extract of 5 log lines from a very simple log. Nothing complicated here. One of the big problems we're facing is parsers. So we need to impose structure on these things. Well, what we do is regular expressions. We're writing regular expressions to extract different entities in here. IP addresses, usernames, number of bytes transmitted, process IDs, you name it. The problem is, Cisco PIX, which is probably one of the most common firewalls, has 4,000 different messages. Completely different messages. These are not just variations of the same sort of structure. You need to write a different regular expression for all of them. That's a lot of work and a lot of potential for error. When we're fusing data, so I mentioned this already before, even in these, this is an extract in a couple of my servers. I have SRV1, which is server 1, which is the host name of one of these machines, but it's also 192.168.1.101. That's the same machine. And even in these 5 log lines, you see both of these items used. If I start doing any kind of analytics, I need to normalize this stuff to actually reference the same entity or the same object. And that's not easy always. A lot of times, if you ask large corporations, they have no idea what assets they have. They can't tell you how many computers they have in their corporation. It's a shocker, but it's true. Go ask any large organization. They can't give you an inventory of the machines they have. Don't try to steal the machine if you work at one of the large companies. That's a failure. The next issue is semantics of data. Right? I can show you on top this stuff. We can parse it. But what's the meaning here? The last 3 log records there are from the same user session. The third and the fourth, the SSHD ones in there, are actually the same logging. It's just when I logged into my machine, that's the 2 records that were generated. Why are there 2 records generated? I just did one action. We have to know all these kinds of things, and that's not easy, I can guarantee you. Here's another log record on the bottom here. I, to date, have no idea what this record means. This is from a Linux kernel message. There's some state change going on, it seems like, from this one number to the same number again. I have no idea what the kernel is trying to tell me. So now, extrapolate this problem. If I don't know what this one record means, what do 100,000 of similar ones mean? That's just getting way worse. A couple other things. We actually need to know how logging is configured. If I look at a log file and I don't see something in there, so there's an absence of a log record that I would have expected, there's 2 things that could have happened. It never happened, that was the thing that I expected, or it was configured not to be logged. If I don't know how the system was configured, I have no idea whether I should expect that log record. And that's a big problem when we're looking at evidence of different incidents to figure out what happened. I'm giving you a little bit of a longer record here, which is just from a proxy log. So when you surf the web, there's this machine in between. It kind of filters in certain cases or caches things. If you look at this, well, is this normal? I can't tell you. I really don't know what the policy is. I'm not exactly sure what someone was surfing to in here. Are they using an outdated browser, for example? There's all kinds of things that could be not normal about this browsing. Maybe this machine is a desktop somewhere, and usually that machine is using Safari. Suddenly there's something showing up with Mozilla Firefox going out. Maybe there is malware on there that's using this browser to go up. I'm not sure if this is normal or not. It depends on the context. And then finally, like, are we even collecting the right information? I enter a lot of corporations where I go in and they have an incident, and I'm like, okay, let's look at the evidence you have. Can you show me your DNS requests, your HTTP logs? They're like, oh, we don't have that. Like, guys, what are you collecting? Well, we have some firewall logs. And, yeah, that's not going to show anything, right? Like, so we need to collect the right information to start with, but that's not always easy, again. So there's some caveats there. So this should give you a little bit of an idea of what we're dealing with here. So let's dive a little bit into data mining, just briefly. And I want to make one assumption, a pretty big one. Let's assume we have perfect data. It's parsed, it's normalized, we understand the log records, so there's no ambiguity. We know where they were generated, we understand the logging configuration, so like happy world, okay? Now with that, how does our data look in general for data mining purposes? We have only about 10 to 20 dimensions if you look at the logs themselves, right? There's 10 to 20 different fields in there. Generally it's time series, we have timestamp data. It's mostly discrete or categorical data. We have usernames, we have URLs, we have IP addresses. These are not numerical values. They're all discrete values. So we have to be we need to find algorithms that actually deal with this. And we have a whole bunch of abstract entities and IP addresses that are really a machine. There's something more. So there's kind of an object model and an ontology behind this, but we don't see that in the data. On the top right, I just have a quick table of a couple of different types of logs, and you see, like web logs have 9 categorical or discrete data dimensions. There's 2 numericals in there. Traffic flows have about 6 numericals, intrusion detection logs have 3 versus 9 categorical ones. So just to give you a feel for what the data looks like. Now, here are some of the challenges that I'm facing when I deal with my data, and I have to probably be honest here, I'm not a data scientist. I'm sort of a hobby data analyst, if you want. One of the things that I learned very quickly when I started talking to actual, real data scientists is that we have no clue what the hell feature engineering is. They're like, oh, but don't you just compute some frequencies here? Oh, the last 5 minutes, the last 15 minutes, and the last hour, how many times did this user actually do something on this machine? Then you can use that to do some Fourier transformations and blah, blah, blah. I'm like, what? So we just use straight up features in the logs, directly what we see in the fields, and we use that. But that's probably an issue, so we need help with feature engineering. Our data is incredibly sparse in terms of entities. What I mean by that is I have log files with 2 million different users having activities in there. The problem is every user comes once, goes away for a long time again. So I don't have these super nice studies where I have users that keep coming back every day or every week. And, I just don't have that, right? It has a long tail. If you look at proxy data, again, there's kind of this box that if you surf at work, for example, most of the traffic goes through this one box that records everything you're doing, every web transaction. Well, guess what? In a lot of organizations, this is 99% Facebook traffic. Well, if I start doing clustering on that stuff, well, I'm going to just cluster the Facebook traffic. But I want to actually cluster the other 1%. Right? I want to see what is sort of the structure in there. So how do I deal with that? And then there's a huge knowledge gap, as you can tell, maybe already by the way I talk about this stuff. We are not data scientists, and we have sort of a fear of you guys because we might lose our job. If you're doing too good of a job and you build a super good system that finds all these things, we're going to be out of a job. But there's one thing, security is hard. A lot of people have tried. And I'm not sure if this example is going to drive it home, but if I give you this example, you have 3 log lines, very simple. Which one is malicious? Well, that's a good question, right? Not sure. Well, I'll give you some more information. This is the Google DNS server, 8888. If you ever need a DNS server that's open for resolving when you're anywhere, use 8888. It's open, anyone can use it. And then this machine here, well, is this a web server or is it a mail server? It kind of serves up both. Generally, that's not a good idea. Just separate different roles on your machine so that you can keep, if like the web server has a vulnerability that your mail server is not impacted. If you have it on the same machine, it's not very good. But just even looking at this, it's kind of hard to tell which one is malicious. Maybe the Google DNS server actually connecting to one of your machines on port 80 on the web. That is kind of strange. Why would Google be interested in talking to you from that IP address? That is definitely sort of suspicious, but I'm not sure if it's malicious, right? It might be that they run a scan from there and verify something. So there's a lot of ifs and whens and yeah, maybe, and sort of you need to know a little more of context. So here are some other issues that we are facing. One of them is, well, we have big data, however you want to define it. We get a terabyte a day in a lot of environments. There's a lot of environments that have way more. So we need to figure out how to run these algorithms distributedly. Like we need whatever you want to try, it needs to work in a distributed fashion. And then a lot of data mining algorithms are just they're built for numerical data, right? They're not built for categorical data. How do I define distance functions, for example, and usernames? There are approaches I can say, well, if they're in the same role, it's a 1, if they're not, it's a 0, but it just makes a lot of things hard, and it's not a straightforward thing anymore. And then a lot of these data mining algorithms, they require some kind of parameters, and there's always like, well, how do you set them? There's assumptions about the data, like it has to have linear separability or certain distributions. I don't know what all that is on my data, right? And then even simpler, what algorithm am I going to use? Like what clustering algorithm should I use in my data? I have no clue, right? And then it's impossible to model all the changing data, because think about this. If you go back to your company tomorrow, a new employee starts, a new machine shows up on the network. Well, is that anomalous? Is that bad? Well, but if the employee didn't start and the new machine shows up, suddenly that is bad. So how do you model all that? I have no idea. Here is sort of a very quick trial of mine to look at different areas in data mining and say, well, where do we have challenges? Well, in anomaly detection, I'm not going to talk about all of it. I'm happy to do that offline. But in anomaly detection, well, how do you define normal? Again, I think I gave you an example. By the way, forget it. We do not have labeled attack data. KDB tried, 99, I think. We had a data set that was created. There has been a lot of academic papers around that, how good or how bad that data set was. We have tried to build better ones, so assume we don't have it. Association rules, we have sparse data, as I mentioned, and often if I run like a frequent item set mining or something like that on my data, I find the heavy hitters. Guess what? I'm not interested in those. Those are generally not the ones I'm interested in. I want the other stuff. And how do I do that? Clustering, I mentioned distance functions that are hard to figure out. Regression, how do I predict the next attack in security? What does that even mean? If I have an increase in volume, suddenly there's a new attack happening? No. But I don't know how to make that link, and I've been thinking a lot about that. If you have any ideas, please approach me later. Summarization, if you do like, we have data seasonality, we have long tails, so that's interesting, but again, it's kind of hard as well. So visual analytics is something that I feel like is something that could probably help us a little bit, not in terms of really solving the problem automatically, but bringing the human back in the loop. And I think we need to, as a data mining community, I think we need to start thinking about this a little more also, on how we can write algorithms or build systems that take the human back in the loop, and not necessarily just solve the problems once and for all, but bring feedback, ask me for feedback as the expert in whatever domain. Because humans, we have incredible pattern detection capability. We remember context. We understand, we remember, oh, Saturday afternoon there was a maintenance window, that's why the server was down. We have incredible intuition, and we have predictive capabilities for free built in. So I'm trying to build systems that enable humans to solve problems and not solve the problems completely. Now, how do you visualize a terabyte of data? That's basically what it comes down to, right? I say visual analytics, you say, show me how you visualize that data. Well, you get a hairball in general, right? Here is the more computer science picture, right? Well, Ben Schneiderman, University of Maryland, came up with this principle: overview first, zoom and filter, details on demand, right? So you take the data set, you can't just dive in and start at the detail. You have to get the overview, understand sort of the rough picture of what's going on, start zooming in, filter things up, pan around, and then once you find something interesting, you often have to go back to the detail, because the visualization is not going to convey all the details in the visualization generally. So you need to go back to the details to figure things out. Well, there's a lot of research also around how this process was augmented. This is sort of, someone might have written about this. This is kind of the version I'm using. I'm running analytics first to generate some kind of an overview, right? From the overview, I do zoom and filter, But in general, I go back to analytics all the time again, running a clustering on the data that I have, sort of interacting with the data, and trying to come up with a data, sort of a candidate data set that I'm interested in. And then I go to the details to figure out what really happened. So taking that process and applying it to actual security problems, I'm going to show you situational awareness, that's sort of overview. I'm going to show you exploration and discovery as the analytics and filter capability, and then details on demand as our use case of forensic investigations. So let's start with situational awareness. What is that? Well, basically what we want, the goal, is to gain insight into a network that, say, has 1 million nodes. That nodes being servers, being desktops, being mobile devices, anything that connects to the internet, that has an operating system on it. How do we get insight into that 1 million node network? That's a humongously big question right now. If you have a solution to this, start the company, get funding, and make money. Now, with that, what I mean is we want to flag issues in real time. So as soon as things happen, we want to know about them. I need you to show me somehow in this overview display. Often, you see, like on the bottom, you see the Norwegian Computer Emergency Response Team, what they're doing to monitor their critical infrastructure. I want to have that show up somewhere on one of these screens, blinking light saying, here's something bad happening. The data we're dealing with is on sort of 4 levels. We have infrastructure data, which is anything from traffic flows, which basically talk about what machines are communicating on the network. So you see like this IP talks to that IP, uses web, or this to that, has an SSH session open, or there's mail traffic. You have intrusion detection systems that are trying to figure out if there's anything malicious going on. They're not that intelligent. They're generally looking for strings in packets and say, well, if I see this string, that's potentially this attack here happening. But there's a lot of false positives, et cetera, et cetera, et cetera. You have router information, you have all kinds of infrastructure data. On the hosts, you can get log files on system hosts that are talking about when someone logs in, when mail is being sent, applications are being opened up. I have metrics on these machines, CPU utilization, how much CPU power is being used, how much memory is being used. I have even statuses of machines, whether they're up or down, because usually at night they're turned off and things like that. On the application side, I have DHCP, so if you're getting on a network like here, you're getting a dynamic IP address assigned. Well, I kind of want to know who that was that got that IP address, because if he's doing something wrong, I want to be able to trace him back. So that's DHCP. DNS, which you probably all sort of know. And then you have contextual information, machine roles, user roles, and there's all kinds of information you can glean from that. Now, the analytics challenges are obviously we have a data reduction problem. We have so much data in all 3 V's. Like, we have a lot of volume, we have a lot of variety, as I showed. Like, we have this data fusion of all these different heterogeneous data sources, and we have a lot of velocity. This stuff comes in at, say, 20,000 events a second. What do I do with that? We want to flag issues automatically, and ideally anomalies. And again, what's normal? I'm not sure. And we kind of need to have the right abstraction on these displays or these warning screens for the right type of user, right? If the CEO walks in there, he doesn't want to know that this one machine is down, that router is not working. But the network engineers do. So what's the right level of abstraction for that? There's sort of 3 approaches. Well, you come up with a visualization that scales, but the problem is I don't really have that many pixels to display 1 billion records. So how do I do that? I have to come up with something. Probably aggregate the data somehow, but we lose information doing so, obviously. And then how do I highlight anomalies? Again, what's normal? How do I score things? There's a bunch of things we can try to do. I have this screen at the bottom right that I crossed out. This is sort of a geographic display where I'm showing sort of attacks happening. You see that a lot in the news, and a lot of people are kind of using that to show these things. The problem is they're useless. I don't care where the traffic came from. So find me other ways to give me situational awareness. Here's something that network operators do a lot. You basically have these different graphs as a view on your network data. How much is being transmitted in a certain amount of time based on different protocols, and you see very quickly there is like sort of one spike there, almost in the middle of the big graph, right up to the right of that line. And then there's a gap almost to the right. So there's 2 sort of anomalies I see very quickly. But these are very noisy, big things happening, right? The subtle things I don't see. Here's another display that I stole, or I got with permission from the German cert. Big display in the middle, sort of volumes. You have sort of indicators, green, red lights, and sort of some Hilbert curve in the bottom right. These are fractal kind of visualizations of IP spaces. But again, the hard part here is coming up with these scores for these alerts to say, well, this is green, or this is red, or this is yellow. And some of the things that people have tried is sort of smoothing things. Here's a very primitive approach for using Holt Winters. It's Holt Winters, not Winter. To basically look at seasonal data. If you look at passer resets, for example, I can't set up a threshold here to alert me. So what I'm doing is I translate this into sort of an approximation. I'm looking at how far away from the approximation am I, and that kind of gives me an interesting score, and I can set my thresholds on that to alert me if the spikes are going too high. But there's still, I don't have enough context in here to actually flag only the important parts. Sorry, I'm kind of rushing here because I'm running out of time. Exploration is basically all about trying to look into data, help me understand, finding interesting patterns, help me find anything. Help me find that APT1 attack luring in my network for 6 months already. Help me look at my historic data, my 180 gigabytes that I have. And obviously very similar challenges, and here it's a lot of sort of interactive views on the data. Here's an example I'm using where I have users on the y-axis, time is on the x-axis, and you basically, every square in here is the amount of activity I see for a certain time and a certain user. You can probably see some trends, blah, blah, blah. You might be able to find some anomalies, but the challenges here are, what happens if I have more than 100 rows? More than 1,000 rows? I have 2 million rows. How do I do that? What am I looking at? What file? Do I cluster and look at certain clusters, and then between different clusters? How do I approach this problem? And I obviously need a lot of data processing to render this stuff. This might be a terabyte of data behind this, right? I'm highly aggregating it here. And I guess what? Hadoop is not going to help you just by the way, because you still have to scan all the data. Hadoop is a completely wrong approach here. Just FYI, is a little bit of a contrast to a lot of what I heard in this conference. Happy to talk more about it. Data leakage example, I have emails here, sender and recipient. I'm doing some clustering on it to see certain groups communicating, but I have all kinds of problems. What is the right layout algorithm? How do I cluster these? What algorithm to use? What are graph metrics? How do I leverage them here efficiently? Running a layout algorithm in a bigger graph can take hours or days just to come back, and I have this hairball, all the nodes collapse into one. Why can't this be, like if you have used Gephi, that shows me how the layout algorithm starts out. I see in 2 seconds whether everything collapses into one or starts getting into a shape. So these are things from a user interaction or from a user interface or an application perspective that you can help me with coming up with better systems. If I have high dimensional data, I like to use parallel coordinates. Great way to look at higher dimensional data. If I have more than 12 dimensions, that's also not going to help. Forensic investigations, I'm going to kind of skip over this. There are other ways of scatter plots. But the question here is, if I show you this, these are logging failures from different users over time. Do you see anything interesting? Yeah, sure, there's some scan on the right-hand side, right? Someone tried all the usernames, but I don't care. It happens all the time. If you put a server out today, you're going to get probably 100 login attempts a day, easily. So what do you do with all that stuff? If you look at the data very carefully, and you have great intuition, you will find the top is sources that came from the US, the bottom is sources that came from Turkey. Exactly the same pattern. Different usernames though. Seems to be coordinated somehow. They're using the same algorithm because the time pattern is pretty much the same. Not exactly. So I challenge you to write an algorithm to find this. But this one analyst had this intuition. He's like, hang on a second. And he found this. So that's where visualization is really, really strong. And I'm going to end with this slide here, where I have a few of the challenges. Basically, we went through this before. But one of the hardest problems or tasks I have is finding the right algorithm for the problem that I have. If you can help me with that, we have solved a big problem. And I guess Jeremy said it yesterday in his talk about deep learning. Just use deep learning and random forest, and you can solve pretty much all the problems. I hope it's going to be the case. They're amazing. But then still there's this art of how to exactly do you apply to deep learning. You have to do some random dropouts and this and that. So put that in a box for me and help me look at my data. There's a couple other challenges here. I have them, the slides are online. If you have any comments, I'd love to hear from you.
Thank you, Rafi. We have time for 1 or 2 questions.
Thank you, Rafi. It's a really interesting talk. And I have a question. So we have very smart visualization, using different visualization mode and our plot for different scenarios. For example, for the first one, and you show the 3 actually different scenarios. Is those actually the selection of the different visualization mode or plot is based on the domain knowledge, or how those actually can be automated in some way in the future, and we can actually identify some different need or scenario to come up with actually proper visualization mode?
I think that's a great question. There is no one way to visualize a certain data set for a certain problem. There's always multiple approaches. There's usually one that helps you quite well, but it usually depends on what data you have, what's your objective to look at. And it can vary a lot. Right? If you have more data, if your distribution is slightly different, then suddenly you might want to use a different visualization. It's something we haven't really spent that much time on, even in research communities, to figure out what are sort of the optimal visualizations for certain data. And I'm kind of missing that. I would like to see more of that. How do I visualize firewall data, for example? It's something that I've been trying to do a lot of work on, but I'm still sort of kind of stuck, because in the end it's also not just the visualization problem, but also this analytics layer, right? So how do you process the data to get it into the visualization is almost the bigger problem than how you represent it.
Go ahead.
I guess this is a relatively simple question, but how important do you think it might be to develop algorithms that are looking at categorical and discrete data versus, because I know that most of what I work with is numerical data, and then I've also realized that doesn't necessarily map as well to applications like this.
I think it doesn't map at all, right? I would love to see more algorithms with categorical data. I think it was one of the points I was trying to make. But I try to use these algorithms, and the first thing is I have to define a distance function. Like, well, it's kind of hard. What's the distance of 2 URLs? I can come up with some schema, but how do I even encode that for a library in R, right? So, yeah, help me with that, please.
One final question from you.
To answer your ask for us to help you, are the data available for other people to study? So for this audience, very typical first question would be, I like to look at the data first, then I can recommend the algorithm to you.
Thank you for that question. And I spent a little bit of time in sort of the security research community when I was back at IB Research in the following years. And that was always a big problem, right? How do we get data sets that are actual good? And I said, we try to simulate them, but please don't simulate actual data. It's not going to work. You can get some data. I think I was mentioning this around to different people here. We need to get the groups together more. Like, if you actually sit at a table with a corporation and say, look, we're going to help you finding issues, I guarantee you, they will let you help them. I know of companies that have built their entire data science teams and started doing research on this data and coming up with solutions on their own. They would love to help some expert input and help in these kinds of things. So I think it's a question of starting the dialogues and being able to go there. You won't find data sets to download. However, if you want a data set to play with, there is something called the VAST challenge out there, V-A-S-T. They have a yearly challenge, and they actually release some really good network logs, and it's a fantastic challenge. Look at that. It's a great starting point. We have some network flows, intrusion detection data, and so on. So it's a good starting point to understand what we're doing.
Thank you.
Thank you.